In this video, I'm going to show you how to solve a system of equations using a matrix. Let's first remember what a system of equations is. It's a series of equations, usually two or three, with more than one variable, usually x and y. Here are some examples that you probably have seen before. You've learned some different ways how to solve systems. You probably learned how to solve one like this by using graphing. You probably learned how to solve one like this by using substitution, or one like this by using elimination. And here's an example of a systems word problem. What you may not realize is that you can solve these problems by using a matrix. Here are your steps. You do not need to write all these steps down because I'm going to give you a shorthand way later, which I encourage you to write that one down instead. So step one, you're going to rewrite the system. This is if needed because some of them are already written in order. So the variables are on the left side of the equation. Keep them in alphabetical order to make sure they are grouped together properly. Step two, create a matrix with the coefficients of each variable as your numbers. Each equation is a separate row. Step three, create a second matrix as a column matrix using the constants on the right side of the equation. Your last step, use the inverse matrix to find the values of the variables. If that all sounds confusing, let's do an example together. So here's our problem. 7x plus 2y equals negative 19. 2y minus x equals 21. So there is some value you can plug in for x and for y to make both of those equations true. So step one, we need to rewrite this equation in order. This is sometimes not necessary. However, this time it is, because notice this 2y and this x are flipped around to put them in alphabetical order. I'm going to put the x below this 7x. I'm going to put the 2y below this 2y here. Notice this negative sign stays with the x, and it stays in the front of my equation. Step two. Now I'm going to write the coefficients in a matrix. So the coefficients in this problem are the numbers in front of the variables. 7, 2. There's an understood number here of negative 1 and 2. Step 3. I'm going to write the constants in a column matrix. My constants in this problem are negative 19 and positive 21. So this slide is going to explain the why of what we do in step 4, why we use the inverse matrix to solve the problem. Think of it like this. If I gave you an equation where I said A times X equals C, let's say A and C were numbers. Let's say A was like 4 and C was 8. So 4 times something is 8. Well, you would solve the equation by dividing by 4. Dividing by 4 is the opposite of multiplying by 4. So if you were trying to solve this equation, because this equation set up, this multiplying problem is going to give you this answer. Look how this 7 times this x is where the 7x comes from. If you take this 2 times this y and just do basic multiplying with a matrix, that's where the 2y comes from. It works the same way for the bottom of the equation. So what I'm trying to do is I'm trying to figure out, well, what number is going to plug in for x and y and make this equation true. In other words, I'm trying to solve for this x, this matrix of x. So I need to get rid of the a by doing the opposite of multiplying by a. Normally what I would do is I would just simply divide by a. That's a problem though, because in a matrix, you can't divide by matrices. So let me think of this another way. Instead of dividing by a, what I'm essentially doing is I'm essentially multiplying by the opposite, because multiplying and dividing are the same thing. They're just opposites of each other. So instead of dividing by a, it's the same thing as multiplying by the inverse, by 1 over a. This is still a problem because I can't type this in as a matrix because I'm still dividing by a in this problem. But I can rewrite this using negative exponents. If I had the matrix A or the letter A and I wanted to rewrite it so that the A was on the bottom, I would use a negative exponent, in this case a negative 1. This is called an inverse matrix because A to the negative 1 is the same thing as 1 over A, which is the same thing as dividing by A. So all that to say, what I need to do in a problem like this is I need to solve by finding the inverse matrix. So I'm not going to divide by A. Instead, what I'm going to do is I'm going to find the inverse matrix of A. If I do it on the left side, I need to do it on the right side. And here the order matters. Make sure you're careful with that. So I'm going to write the inverse of A first, and then my other matrix second. That's the Y. So now let's actually get to it. So what I would like for you to do, if you have not yet, is go to desmos.com/matrix, and we're going to type in those two equations. So there's A and there's B. So let's go to and let's type those in. So you're going to click on this blue button that says New Matrix. It's already set up as a 2 by 2, and I'm going to type the coefficients, the 7, the 2, the -1, and the 2 in my first matrix A. Enter or hit New Matrix. And for matrix B, I'm going to type in my numbers for my coefficients, the -19 and the +21. Notice I have to change my number of columns to a 2-row, 1-column matrix. And then you can hit enter, or you can simply hit this button at the very bottom right of your corners of your screen. So what I need to find is I need to find the inverse matrix of A. So I'm going to type in capital A, and I'm going to do an exponent. You can type in this -1 button here. -1 power, which means the inverse of matrix A times matrix B. My answer is over here in the bottom right corner, -5 and 8. So let's talk about what those numbers mean. So solve using the inverse matrix A to the -1 times B, and it gives me this answer here. As a reminder, from a couple slides ago, we said that the X was on top and the Y was on the bottom. It works the same way when you have your answer. Remember, with the X is on top and the Y is on the bottom, that gives you your final answer so that your X is -5 and your Y is +8. You could write it as a equation like this, X equals 5 and Y equals 8. X equals -5 and Y equals 8, or you can write it as a ordered pair, -5, comma 8. Both answers will be right. Or you could leave your answer as a matrix and put -5 over -8, which is important why we keep our numbers and our letters in the same order back in step 1. Otherwise, you could get a different answer as your result. Let's try a couple examples on your own. So I encourage you in this part of the video to pause the video. So let's try number 1. So I encourage you to pause the video and try to set up your matrix. Hopefully by now you've set up your matrix. Let's go through what your matrix should look like. I'm going to slide this over a little bit. So your numbers are coming from the problem up here, -3 and 7. Here's your top row right there. -9 and 5. Here's your bottom row right here. For your coefficient column matrix, -16 and 16 are listed on this side. Now do the inverse matrix. So A inverse matrix times B, and see if you get the same thing that I got. This means that your X is equal to -4 and your Y is equal to +4. Let's check number 2. Notice it's a little bit different because you have 3 equations, not 2, but it's still set up the exact same way. Be careful with your second row. Again, I encourage you to pause the video and see if you can set up your matrix. Let's check your matrix first. What you should have, anytime you have a letter with no number in front, it's an understood 1. So all of these numbers, that's where the 1 is going to come from. Notice in this second equation, 3 is your X, that's where the 3 is. 2 is your Y, that's where the 2 comes from. There is no Z. So no Z means a Z value of 0, which is where the 0 comes from there. Your column matrix is listed over here on the right-hand side of your equation, -6, -25, and +12. Now do your inverse matrix and see if you can find your answer. Hopefully you got the same thing as I did, -5, -5, and 3, which means your X is equal to -5, your Y is equal to -5, and your Z is equal to 3. I hope that was helpful.